if we look at the range, where people go wrong is most people understand what the range is. They go, it's from like 2 to 10, whatever that is, but that's not actually the range. Even if you said the data is of a range from 2 to 10, that's not the answer, because range is one number, all right? So the range is always one number. So it's the difference between the maximum score. What's maximum mean? Highest, okay? So that's the word we need to use from now on. The maximum score and the minimum score. Minimum means lowest. And on our calculators yesterday, we looked at how to do that just from like within those statistics, what came up, min X, max X, they're those two scores. So your calculator doesn't give you the range. It gives you the minimum and the maximum score, and you have to work out the range. Everyone understand that? Now, if we have a set of an example, so if we look at a range equals max, take min, it will be like a formula for this. So e.g. 8, 2, 3, 12, 20, okay? I've got these numbers. Our range would be 20, take 2. Now, this is where I said people make mistakes, is that people don't write this, people write 2 to 20. That's what they write. And they get the mark wrong because I would go, no, that equals negative 18. So you can't do it that way. It has to be a one number, so it's 20, maximum score, take the minimum score, which equals 18. So your range is 18, one number. You can't write 20, take 2, either you have to actually write the answer. Yes. Yes. You'd probably have to say, not in group, I don't know. Any questions? Hudson, can you stop this? All right. Everyone good with range? Okay, what other sorts of measures of spread do we know about? Standard deviation. Now, box plots we're going to do next, which includes, what does it show in a box plot though? What sort of interquartile range? So the third one is interquartile range, and that's the one we're going to do tomorrow, and then we'll do box plots from that as well. Okay, so today is about standard deviation, and I think standard deviation is the one which is the most confusing, so I really need everybody to be focused for the next sort of 10-15 minutes, but as long as you get the understanding of what it is, I think you'll get it. Okay, so it's just about focusing in and really understanding it. So our second one for today, and this is what we're focusing the lesson on really, is what's called standard deviation. Now, standard deviation is used in real life all the time. All of your tests, you'll have a mean and a standard deviation, okay? And it tells you something in particular. So the range is the range spread off from the minimum to the maximum score. What is standard deviation? Does anyone know? Yeah? Yeah, okay. So if you've got the mean here, it's the average distance or the mean distance of the scores away from the mean. All right, so when I say that, so let's write that down and then I'll show you some pictures. Okay, so the mean of the distance, of each score, the mean of the distance each score is from the mean. The problem is you've got two means there, okay? But I'll explain it in a second. The mean of the distance each score is from the mean. Better to actually show you than to write it. But it's saying, if you use the word average for mean, it kind of helps you a little bit. So the average distance of the scores from the mean. It's saying how spread out from the mean it is. So if I have a test mark, So if we did a quiz, let's look at this class and make it we only had 5 people in this class. Okay, 5 people, these 5 did a quiz, okay, out of 10, and the mean of those scores was 5. Okay, so everybody got, well, no, the mean was 5. Right? So this is 5, and that's the mean. Remember, that's the score for mean, right? To get that mean, there's lots of different ways which we could do it. Someone could get 0, someone could get 10, while 3 people got 5. Someone could get 5, someone could get 6, someone could get 4, someone could get 3, and someone could get 7. Ends up being a mean of 5. There's lots of different combinations of things, okay? But let's assume, instead of that big combination, that everyone got 5. All right, so if all 5 people got 5, so remember, like, this is like a dot plot, each dot is a person, all 5 people got 5, okay? The mean is also 5. Okay, how far from the mean are each of those scores? 0, they're on the mean. So therefore, the standard deviation, the average distance from the mean of all the points is 0. So this is the time when standard deviation equals 0. If all the scores are exactly the same, then the mean is that number and the standard deviation is 0. There is no deviation from the mean. They're all the same. Can everyone understand that? All right, so let's think about this in a different way. What if I still had those same 5 scores and the mean was still 5? But this time, someone got 5, someone got 4, someone got 3, someone got 6, and someone got 7. You'll notice the mean is still 5. And if things are symmetrical around the mean on a dot plot, where it is symmetrical, where that mirror line is where the mean is. So our mean is still 5. Now let's look at each point. I'm going to highlight it. Okay, so this point here, that person got 5. How far away from the mean is that person? 0. So we've got a 0 there. That's our yellow point. Everyone got to there? All right, so now if I look at the green one, which is now green, how far away is that from the mean? 1. Okay, it's 1 away from the mean, so one of our scores, another score is 1. That's the green one. Okay, what about the purple one? How far away is the purple one? It's 2 away from the mean, so we've now got another score which is 2. Everyone see we're just finding the distance from the mean of each point. All right, so then if I look at the ones below, hopefully I've got some more colours. Okay, so blue one, how far away is it? Now it's 1. What we need to be aware of is if we were trying to do this in like a formula, it would actually be -1, okay, and which is why we have to do something in our formula later on. But in essence, for this example, we're just going to say 1. It's 1 away from the mean. And then the last one, how far away is it? 2. So we've got this set of scores, which are the distance from the mean. So it's distance from the mean of each score. We've got like a new set of scores. Is everyone okay to there? Yeah? All right, so standard deviation is the mean of the distance from the mean of each score. So what do I have to do? I just have to add them together and divide by 5. So standard deviation is equal to 0 plus 1 plus 1 plus 2 plus 2. Just sort of mix them up in the order there, divided by 5, which is 6 divided by 5, which is 1.2. And it's saying the average distance from the mean of those 5 scores is 1.2. And that's what standard deviation means. So this one, the top one, was 0 because the average distance was 0. This one is 1.2 because the average distance was 1.2. Notice the 2's have kind of pulled those scores out a little bit more. Can everyone understand the concept of standard deviation? Yeah? So if we then look at this, pardon? There is, it looks like, I'll show you in a second. Like literally, okay. So if we look at this, this is the sort of question you get in a non-calculator section where I'm going, do they understand what standard deviation is? You don't get a calculator to work it out. You get given something like this. So I'm going to give you 2 scores, 2 dot plots, and I'm going to tell you that the mean is here and it's X. I'm going to give you another one, and I'm going to say the mean is the same for both of them because it's also there. All right. Now I'm going to have dots here, and then I'm going to have dots here. So same amount of scores, the same mean, which you can tell because they're symmetrical around a point, that the mean's going to be in the middle because they're symmetrical, right? So the mean is the same. Which one has the highest standard deviation? Which one has the highest standard deviation? The second one, because there's more points which are, Gabby, more points which are further from the mean. So this one has the highest standard deviation. This one has the lowest standard deviation. And if you can understand that, then this isn't going to be too hard for you. That's really the understanding of what it is. And this is really where we test you in a test, is actually your understanding of standard deviation, what it means, that it's more spread out from the mean, less spread out from the mean, because it's really easy to find this out in your calculator. So it's more about your understanding of it. Any questions to there? All right, now I'm going to show you today how to find out the standard deviation by hand, like using a formula. You are not expected to be able to have to do this because it takes a really long time. So we're pretty much going to do one example together and you're going to do 2 in your homework and then you're never going to have to do it again. But you need to understand the processes and the words involved in doing it. But then you can use your calculator to do it after that. You understand? Want to code that? So to find, now I'm going to call, it's called by hand, but you're still using a calculator, but it's just showing you the process, all right? So to find the standard deviation. Now in your calculator, the symbol you're trying to find, I'm just going to copy it from the other notes because it'll take me ages to open up my calculator, is this one. Why can't I copy it? Hang on, maybe if I get rid of this. Is that symbol? Can you guys see it? Yeah. Perfect. All right, is that symbol there? All right, so it's underneath, it's got an SX with it next to it. It's underneath, it's the one we were actually missing when we did the cut and paste yesterday with our calculators. It's before minimum score when you bring up the data. So it's right there, it looks like that. Now, when I put the numbers we're going to use for our example in for today into my calculator, that's the answer which came up. So we're going to see if this process brings up the right answer, okay, if we do it in the actual process. So our example numbers we're going to use just for this one is 3, 5, 8, 12, and 17. So we've got this set of numbers and we've asked you to standard deviation. We need to find the average distance from the mean. Now, while we're doing that, have a look at the numbers we had up here. You know how we had the 0, 1, 2, 1, 2 there? And you know how I said here that this would be -1? and this would be -2 because it's going backwards. -1, -2. Now, if I used -1 and -2 instead of +1 and +2 in here, what would I end up with? If I said 0 plus 1 plus -1 plus 2 plus -2, I'd end up with 0, okay? So, in this process, we can't use the positive and the negative numbers because we're finding the distance from the mean. We're always going to end up with 0 there otherwise. So we have to do, this is why we have to do something extra in this. I'll show you what, but that's why, just so you know. All right, so step 1, if we're finding the average distance from the mean, what do you think we have to do first? Find the mean, okay? So step 1, find the mean. There's only 3 steps, okay? One of them is just a bit long. Find the mean. So 3 plus 5 plus 8 plus 12 plus 17 divided by 5. So our mean is 9. Okay, so we have to find the mean first. Now, if I go through a process, which I'm just trying to like set it up in my calculator so it works all the time, how do I find the difference between two numbers? When we do one, take the other, okay? And so what we have to do is we have to find the difference between each of the numbers, but remember I told you that they're going to end up with positive and negative numbers? We need to only have positive numbers. So if I have like -1, what could I do to make it a positive number? I could just add 1 or end up being 0, but I can't add 1 each time because we don't know it's definitely going to be 1. It could be -8 or something else. How do I make something? What do I have to multiply it by? I have to multiply it by a negative number. And so the easiest way to do it is to multiply it by itself. And so what we do is we actually find the difference of each number and then we square it to make every number positive. So am I going to make all the numbers bigger, hey? How do we unravel squaring numbers? Square root. So we've got to remember that's got to be a process somewhere at the end. All right, so step 2, it's not as hard as it looks, but we just got to remember the reason we're going to square the numbers, so later on we have to square root the numbers to get the right answer. All right, so what we're going to do is step 2 is we have to find, and this is where I said you need to know a word, find it's called the variance. Find the variance. All right, now the variance is each score subtract the mean. So that's where we're finding the difference. So we get each score and we subtract the mean. That's going to give us the difference, whether it's a positive number or a negative number. We then need to make it positive. So we then square it, squared. It'll make more sense when I show you the example. Squared. Okay, and then we find the mean of those numbers. So then added together. Oh, that's a few too many D's. Added together and divided by how many scores there are. So for that, we're finding the mean of them. We're finding the mean of the differences squared. So that's what variance is, the mean of the differences squared. That's pretty much what we're doing. So to do that, we look at each score. It's going to be quite a long working out. Variance equals each score. So the first score was 3 and the mean was 9. So we go 3, take 9, which is -6. But then because it's -6, we're then going to square it and make it 36. I'm going to say plus the next score is 5, take the mean, squared. Plus the next score is 8, take the mean, squared. Plus 12, take the mean, squared. Plus 17, take the mean, squared, all divided by 5. because there's 5 scores in total. So we take the mean from each score, square it, find the mean of those numbers. So we could then say 36 plus 16 plus 1 plus 9 plus 64 squared. Notice they're all positive numbers now because of that squaring. And so we find out our variance is, and I'll give you time to write this down, variance is 25.2. Yeah. It's 5 digits. Oh, I didn't. I just wrote the wrong number. Sorry, I'm like, what? Huh? All right, so that is what's called the variance. It's the mean of the difference from the mean squared. Yeah. Yeah. That equals 25.2. When you put, we have it. So right now, this is the mean of the differences squared. So to find the standard deviation, we square root the variance. And that's our final step. So we now just need to get rid of those squares. So step 3 is find the standard deviation. Which is the square root of the variance. So the square root of 25.2 is 5.019. Where have we seen that number before? Up the top here, 5.019. Winner. All right, so that is how, so even though if you just put those 5 digits into your calculator, and then you go stat, caps, etc., one variable comes up with that answer. It's way easier than working out by hand. But you need to understand the process involved. Okay? So that's how you find it, how it works it out. You will not be asked to find the standard deviation through that process. But I'm going to get you to practice it once today, just so you get the process. All right? Any questions about that? Any questions about standard deviation in general? All right, so we're going to do some practice. Now, you guys have enough time to actually be able to get this done, get the first part done at least. So exercise, now make this really clear. If you don't listen right now, you're going to do way too much homework. You're going to do exercise question 1A, only A. You're then going to do question 3B, only B. But you have to do it with the whole process for 3B. 1A is just asking for the range, okay? So it should take you 10 seconds. 3B is asking for the standard deviation with a list of numbers, but it's not too many. Okay, so you have to do it once. Yeah, that's the only one. Be lucky the other class had to do 2 of them. I'm being nice to you guys, okay? Question 4 to 8 are like those dot plot ones where you need to say which one has a higher or lower standard deviation. You don't have to actually work out the standard deviation. And then exercise 3B, you can use the stat function on your calculator. They're just like which one has a higher standard deviation, etc. Exercise 3B, I'd like you to go through as many as you can of exercise questions 1 to 14, every second question. You're not going to get through them all today, but just give it a try. Any questions? 3A, you should be able to get done, I reckon, in the next 10 minutes easy. If you're working. So you could do the square root of this. It's just relating to the fine. Just trying to show the process. I will give you your investigation marks. However, as I said, I'm marking Mr. McManus's. I've marked yours, and now I'm marking Mr. McManus's. So please don't share it with them because they're not going to get theirs for another couple of days till I get them finished. All right. So I'm sorry I started marking yours before I got theirs. Yeah, but only once. It's the only time you're ever going to have to. It's just